Hello everybody, this is Jeff Janess and welcome to our 7th lab exercise in projections and datums. This time we're going to take a look at projecting raster datasets. And I'm wanting you to see, well, partly how to do it, but more to see what damage you can do to a raster by projecting it. Sometimes we have no choice but to project raster datasets, but if there is a choice, we should avoid it if we can. And I'm hoping this lab exercise can convince you of that. All right, so first off, we're going to try it with this Coconino EVT. This is a landfire vegetation type on the Coconino National Forest. The EVT is existing vegetation type. It's a few generations old. There's newer data, but this is a good exercise to work with. All right, so let's go add that. It's in our additional data folder. Here it is. Okay, so we're going to project it. Actually, what we're going to do is project it into a geographic coordinate system and then project it back into this coordinate system. If you had a vector data set and you projected it once and then projected it back to the original, it would be almost unchanged. The vector system is so precise that the projection functions really don't change it much. But rasters are not that way. Remember, rasters are a bunch of rows and columns, and when you project, it has to create a new set of rows and columns, and it just can't do that without changing things. And so we're going to do 2 steps in this projection, and we're going to see the damage that causes. Now, first off, let's take a look at what coordinate system this is in. Open the layer properties and the source and spatial reference. Okay, this is actually a custom projection generated off the Albers equal area general projection. It's just got special standard parallels and central meridian. But the point here is that this particular coordinate system is not one of the predefined coordinate systems that you have available. So when we project back into this, it's going to be a little more tricky to get this coordinate system. But I'll show you a way to do that. All right, so that's the coordinate system. Let's open up the project tool. We're just remember it was in a coordinate system projected from NAD 83. So we're just going to project it right into the NAD 83 geographic coordinates. Analysis tools. Here's the project raster tool. Let's pop that open. Drag our raster in. I'm going to call this new raster just Albers. The output coordinate system, oh, this is not Albers. This is going to be in NAD 83. The output coordinate system is, let's see, I believe I have a well-known ID value for you. Here it is, 4269. There we go. We're going to resample using nearest neighbor, and that's because this is actually a veg type raster. And for these type of categorical data sets, you definitely want to use either nearest neighbor or the majority. The other two, bilinear and cubic, will take an averaging function. Nearest neighbor and majority will make sure that all the new raster cells, or excuse me, all the new raster values existed in the original data set. And maybe let's change these numbers so it's actually something we're used to seeing. Just pop open the symbology on this, and we will symbolize this raster according to one of the attribute fields. EVT name is a good one. Why not go with that? There's others. Yeah, let's do the Society of American Foresters and Society of Range Management. That's a good one. All right, so anyway, now it's classified. All right, so we're going to use nearest neighbor. We're just going to accept the default X and Y size of the new raster. This is how big the new raster cells will be. Remember, this is a geographic coordinate system, so the units are in degrees, and that's why these values are so small, 0.0003. Okay, there's our new raster. Now the point of this exercise is to project it back again into the original one. So let's take this projected version, bring it in as the input. The output we're going to call back to Albers. All right. Now the coordinate system. It was that custom coordinate system that the original dataset came in. It wasn't one of the predefined ones. We could actually get to it since it's a layer in the map right now. We could come down here and this is it. But I also want you to see this function. This lets you import a coordinate system. All this does is you select a data set, and then the tool will grab the coordinate system of that data set and apply it to this tool. So we're just click on that. That's our original data set. The tool will grab the coordinate system from that. Did that, and now it popped it into here. All right. Now it's wanting to make the new cell size larger than it used to be. The original was at 30 meters, so we'll just set this back to 30. And 30. Okay, and hit go. Okay, all done. Here's our new raster. Let's close that. Let's set this back. Let's set this to the same symbology that our first one was at. We're going to symbolize it based on the Society of American Foresters system. Okay, there we go. Now if we look at these just from this perspective, they don't look that much different. You can tell there's a little bit of difference as we switch back and forth. It covers the same general extent. But we're going to see issues as we zoom in. Because what if there were actual specific cells that we were concerned with? If we switch back and forth here, we can start to see that many of the cells have changed value. And that can be a problem. If you have a sampling point out there and it's sitting in the middle of a little spruce fir stand, and you run this projection tool on the raster, and all of a sudden this point says it's in a meadow or a ponderosa pine stand, that's kind of important. And projecting rasters makes this happen. If we went to that intermediate one, you might see that they are all twisted and turned. That's because it's in a different coordinate system that is just naturally going to twist it. But anyway, that's the lab exercise, and I hope it makes sense.